All right. Before we pick up where we left off yesterday, yes, we are going to need a calculator today, so there should be at least one around on somewhere of the desks. If you have your own, you can go ahead and use it. Does anyone need a calculator, though? Need one?
I love my schedule. Like, because by the time I'm done with it, I'm like, oh man, I'm in the job already.
All right, so yesterday we were looking at how we can analyze an equation by hand to determine where its graph is specifically above the x-axis, below the x-axis, on the x-axis, all those different characteristics, okay, without necessarily needing the graph to help us with that. You're going to have to help me out because everyone always ends up in a different space, or a different place, rather. Did we finish page 126?
Yes.
Yeah? We're on 127?
We have not started 127.
There we go. All right, so we'll change the page. We're going to try to take a look at this example without a graph, okay, given to us, so we'll see how far we can get. So just to kind of reiterate or review from yesterday, we are creating what's called a sign chart or a number line sign chart to help us determine positive or negative locations or intervals. So we first off need to find those special numbers that we put on the number line to help us divide it up into little intervals. What are those special numbers that we're looking for in these examples? When we did absolute values, the special numbers were the vertices. What about the special numbers for these polynomials? Yeah. The x-intercepts. Okay, so yesterday and the day before or the week before, we were working on factoring to help us find those x-intercepts. If you take a look at the example on this page, notice how your equation is already factored. You have those individual parenthesis pairs or sets. So what's nice about this example is we actually have less work we have to do. It's already factored for us. Can we determine the x-intercepts based off the factors? So at first glance, I see 3 x's. We should probably have 3 answers. Okay, one for each. Can we think about what the solution for the lonely x out front would be? 0, okay? And then the next x would be -2 because we have to counteract that +2. And then the other x would be +2 because we got to counteract the negative. Okay, so we have 3 x-intercepts. We'll go ahead and draw our number line, and we'll write in those x-intercepts in order. So if these are the 3 places on the graph where the graph is on the x-axis, that means any other point or x value you want to pick is either above the x-axis or below, because those are our only 2 other options. So we're going to go ahead and test specific x values within those intervals to see how the graph is behaving. Is it above the x-axis or is it below? So for our first interval here, pick any number you want for x between -infinity and -2. -3. All right. So we're going to plug in -3 for every x, and we're going to see what the sign of each individual factor would be. We're either going to write down a positive or a negative. Okay, no numbers. So if we plug in a -3 into the first x, notice how there's already a negative out front. So the double negative would change this to a +3. So we'll just put a little plus sign. Right, so the first factor, in this case, it looks like the GCF would be positive. If we plug in -3 into the middle factor, we'll have -3 plus 2, which is -1, so that would be negative. And then if we plug in -3 into the other x, -2 would be -5, and then square it. Positive, right? -5 times -5 would be a +25, so this ends up being positive. So if each individual factor has these signs, we're multiplying all those together. So what are we overall on that interval? Negative. Positive times positive would be negative. Right? So we're just going to repeat the process for all the other intervals just to see what our overall sign would be. So for the next one, maybe you want to pick -1. If we plug in -1 for all the x's, pretty sure we'll get positive, positive, positive. All multiplied together would be positive. For the next interval, you'll pick +1, plug it in for all the x's, we'll get negative, positive, positive. So overall we're negative. And then anything bigger than 2, maybe you'll choose 3, will be negative, positive, positive. So overall we're negative. I think this is a good example for us to see because the ones we did yesterday, I'm pretty sure they alternated, like positive, negative, or vice versa. It is possible for you to have a negative, negative, or a positive, positive. So don't get used to or accustomed to or just assuming that it's always going to alternate. Okay, this could happen. So let's go ahead, and now that we have the sign chart completed, we're going to analyze the question at hand. Okay, what is it asking us? So using the symbol less than or equal to 0, we're graphically trying to determine where we are below or on the x-axis. So the question is, how do we analyze or read our sign chart to help us determine those intervals or those places? Can we think about what we should be looking for if we want to be below or on? What do you think, Logan? X-intercepts. Okay, so we should be able to include these x-intercepts because those would be on the x-axis. So we're probably using brackets to include those. All right, so that kind of fits the on description. What about below? If you're below the x-axis, you are negative. Okay, so this interval and then these ones over here. So if we take a look at the first negative section, if this is going to go all the way towards negative infinity, we're definitely going to use a bracket there. And Logan said that we can include the x-intercepts, so we'll have to do a bracket on that -2. So I think that one's kind of clear-cut. The other two can be a little confusing or tricky because they are back-to-back. Can we think about how these might operate to give us our interval? Do we do two individual intervals because like this is negative, this is negative? Can we make it just one big interval because they're both negative back-to-back? What do you think? What do you think, Noah?
It's or equal to 0, so you can actually just go straight through them.
You can go straight through. So you are on the x-axis at 0. You are below the x-axis in the interval. You are on the x-axis at 2. You are below the x-axis on the second interval. And if this is going all the way towards infinity, we'll just use a parenthesis there. Okay? So I know you might be tempted to do two separate intervals because we have two negatives there. But the fact that we can include two technically means we would do bracket, bracket. But if you can include two anyway, you can just make it one big interval because every point within these sections is satisfying this example. Okay, below or on the x-axis. So if we go ahead and write that, we're going to need parenthesis, negative infinity to -2 with a bracket. And then we'll do u, bracket 0 to infinity with a parenthesis. Now, I started this example off by saying we did not have a graph to actually check our work, but that's because I didn't want you to know that the graph on that page is the actual graph of the function. So if this is the graph of h of x that we just analyzed, does our answer actually make sense? Notice how we're below the x-axis from -infinity to -2, and then from 0 all the way for the rest of the graph, we're also below or on it. Okay, specifically on it at 2. So it's nice that we do have the graph to kind of check our work, but notice how we got the correct answer without actually needing it. Okay, we're eventually going to have to trust our work, okay, trust our gut, and make sure that we're familiar and comfortable with this sign analysis, okay, positives and negatives. So my question is, though, what if we wanted to mix it up a bit? What if, let me zoom out a second here. What if I changed the inequality? So instead of being less than or equal to 0, like the original question was, what if I changed it to greater than or equal to 0? How would that change our analysis? What are we looking for here? Go ahead. Okay, so above or on the x-axis. Okay, on because we have that equal bar. So I'm curious, how can we get this solution based off of our sign chart table? What should we be looking for in this case? If we want above or on. What do you think, Julia? Okay, positive, definitely for the above. And then on means we should be able to include those x-intercepts. Yeah? Is that what you're going to say? Yeah. I'm sorry, Caitlin. Okay, so we should be able to include those x-intercepts. So we can do bracket -2 and then bracket 0. Is that it? Is this the only spot where we are above or on the x-axis? Say it louder.
We're on it at 2.
We're on it at 2. And this is what's tricky because it's kind of hidden. If you take a look over here, since these were back-to-back negatives, you might lose sight of the fact that this is an x-intercept at 2, meaning you are on the x-axis. So we actually have this interval, but then we also have this particular point. Okay, it's kind of hidden because you have those back-to-back negatives. So if we were to write this out, we'll have the interval -2 to 0 with brackets. But then we also have to show that we can include a specific point. So an interval is normally a beginning and ending location. A point is just one value. So we're just going to go ahead and write 2. This is just telling us that we are above or on the x-axis on this interval and at this point. Okay, that location. And if we look at the graph, I think it should make sense as well. Notice how we're above, bless you, from -2 to 0, and then we are specifically on at 2. Okay, so be careful with your sign chart. Everything is there. We just have to be comfortable or confident on how we analyze it. Okay, kind of hidden, but we need to make sure that we can see that. Okay, we're going to try one today that's calculator based. That's why you needed your calculator today. Let's try this one. Consider this polynomial. How is this one a little bit different than the previous ones we've been working with? Yeah?
It's not set to 0.
It's not set to 0, so let's make it be 0, because 0 is the x-axis location. We want to compare it to that value. That way we can see where we're above, where we're below. Okay, so we want to, we'll say, compare to 0. Okay, that's nothing horrible. I mean, we just have to move the 3 over. I know we can do that. So x cubed minus 9x minus 3, and then we'll have the 0 on the other side. So now that it's in polynomial form, we're comparing it to 0. This is when we want to try to factor to try to find those x-intercepts, create our number line, do our sign chart, see where we can go from here. So what are some factoring techniques that you might want to try for this one? Should we roll through our options? Is there a GCF? No. Does it fit the I am setup or profile? I'm seeing head nods and head yeses. This one's a little tricky. It does kind of look like I am because the leading coefficient is 1, okay? But why is it not? Why can we not factor using this technique? What do you think, Carter? It's cubed, okay? This power and the other power on the x should be halves of each other. So normally this would be 2 and 1 if it was a quadratic. This should be 4 and 2 if it's a quartic. You can have 6 and 3 if you want a power of 6. So unfortunately it does kind of look like I am, but that power of 3 is throwing it off. Okay, no go. So we can't use that technique. We don't have 4 terms, so grouping's out of the picture. And since this wasn't able to be done using that I am method, we can't really do divide and slide either because the powers aren't matching up. So unfortunately, there's no way for us to factor this particular function. Okay? That doesn't mean we can't figure out where it's above, where it's below. We just can't do it using the sign chart process. Okay? Because we need to figure out where those x-intercepts are. And that's when we're going to rely on a graphing calculator to help us find those. Okay, so on your calculator, we're going to go ahead and type in this function just to get a good picture of it. Now, depending on which calculator you're using, it might already be in there from last class. Okay. So we'll go ahead and type it in. Before we hit graph, let's go to window to make sure we can all see it clearly. And we're going to try to plot it on our notes. Notice how the x-axis goes from -5 to +5, so we can type those in appropriately. But we don't have y tick marks, so this is when we need to choose the y scale, and you can make it whatever you want. Do you want to keep it -5 to 5, or do you feel like changing it? Is that okay? We can do -10 to +10, we can change it whatever. How about we see what it looks like here, and then we'll decide if we need to change it. Okay, so if we hit graph, that looks pretty good, but if you saw how it was graphed, like the path of it, we should have a maximum up here and a minimum down here somewhere. So maybe we do have to change our window a little bit to make sure we can see those. So we want to make the graph taller, so we're going to change the y values. Instead of -5 to +5, what do you want to change them to? 15? Okay, -15, +15. Ooh, that's good. All right, nice and clear. You can see the curves, you can see the maxes and mins. I like it. So what we're going to do is try to find those x-intercepts using the calculator. And if you look at the x-axis, notice how the x-intercepts do not fall on tick marks. So if we were able to factor it, I mean we weren't, but if we were able to factor it, they would have been very complicated factors that would have led to decimal results. So it kind of makes sense why the calculator might be a little bit more appropriate for this example. So I'm curious, do we recall from earlier this year how the calculator can find those x-intercepts for us? Are we familiar with the buttons or the menus where we can go? We'll write them down, but I'm wondering if we remember. Yeah?
Your second trace and then 0.
0. Okay, so hit the second button and then trace. That's going to bring you to this calculate menu. It was kind of our go-to spot earlier this year where we had all of our characteristics listed. Okay, so we're going to write this down. We're going to hit second, trace, and number 2 would be 0. Okay, 0 meaning x-intercept. So go ahead and select that option. The moment you select it, that little cursor spider dude should pop up on your screen. And we're going to move the cursor to where we think an x-intercept is located. Now, we essentially have 3 of them to calculate, so it doesn't matter which one you do first as long as you do all of them. So maybe just we'll work left to right. Okay, so let's say we'll move cursor to our guess. Now you might not be able to put the cursor exactly on the x-intercept, but as long as you're close, that's all that really matters. So once you are at a spot that you think is an x-intercept, the calculator is going to ask you a few questions. Okay, so on the screen it should say left bound. You're going to hit the left arrow a few times, maybe like 2 or 3, and then hit enter. Okay, you should see an arrow pop up on your screen. The next question is right bound. So you're going to go back to where you think it is, and this time you hit the right arrow a few times, maybe 2 or 3, and hit enter again. You should see another arrow pop up on your screen. So this is just a way for you to tell the calculator that the x-intercept you want it to find is somewhere between those arrows. You're making the calculator's life a lot easier. So instead of checking the whole graph, it's only checking this little section. The last question is a guess, so you'll just go back to where you think it is and hit enter. So when you're done with that process, like left point, right point, guess point, the 0 word should pop up on your screen and you'll have the x location exactly. Okay, so we'll write down -2.817. And maybe we'll plot it on our graph. Okay. So just to have these steps down, we do second trace, number 2 for 0. We're going to move the cursor to our guess. We'll say pick left bound. Is it not working?
It's working funny. I mean, it got the same x value, but its y is like weird.
Can I show this for a second?
Yeah.
Okay. So this is what Blair's calculator. Whoa.
It's backlighted.
It's backlighted, yeah.
It's not gonna work. You just
Oh yeah, I know how to do it.
Can you do it? Can you change it?
It's this one.
No, I want you to leave that on there. Do you know how to change the brightness?
Here,
I've done it before. I don't remember.
hit second and then the down arrow.
Is that better? Okay.
It's a little better.
There we go. All right. So take a look at Blair's calculator. If you take a look at the bottom screen, notice how his y value is 1e -12. Do we know what that e stands for? It's scientific notation. It's your calculator's scientific notation. So even though mine was 0 exactly, Blair's would be what? 0.0000000001. Okay? That's pretty darn close to 0, right? So I don't know why your calculator chooses to be that specific, but it's basically 0, okay? You do get roughly, or actually the same x value. It just chooses to be highly specific for your y, okay?
You get 0 perfectly if you plug in. If you just add a second line. And
Do you? All right, pick left bound, enter, pick right bound, enter, pick your guess, and then enter. Is that coming back to us a little bit from earlier this year? Yeah. What's interesting is the maxes and the mins work the same way. We had to pick a left point, right point, and then our guess point. This is the same process for x-intercepts. Now, that was all wonderful. We just got to repeat the process 2 more times because we have 2 more x-intercepts. So repeat it. We'll go second trace, number 2. Move the cursor to where you think it is. We'll do left a few times. hit enter. We'll do right a few times, hit enter, go back to where you think it is, enter. And as long as that word 0 is on your calculator, that's what we're looking for, okay? Your Y value might be that weird scientific notation, but as long as that word is on there, they're telling you that's your x-intercept. Okay, so this one's negative 0.338. All right, we have one more to find. Second trace, number 2. Move it to where you think it is. Left a few times, enter. Right a few times, enter. Guess. 3.155. All right, so now that we have our x-intercepts and we have them plotted on our graph, we're just going to go ahead and draw a rough sketch as to what this looked like. Okay. And now, since we have a picture of the graph, the sign chart might not be necessary because we have the visual aid. Okay, so based off the graph and the picture and these x-intercepts that we found, let's see if we can figure out where this graph is greater than or equal to 0. So analytic or graphically, we should be looking for where we are above or on the x-axis. Anybody care to take a shot at it? You want to give a shot, Travis? Yeah.
Like the answer.
Yep,
Okay.
the intervals. Yep.
I got bracket negative 2.817.
Okay.
And comma negative 0.338, and then bracket, and then U, and then a positive 3.1545, comma infinity parenthesis.
Love it. Okay, so looking at the graph, we are above the x-axis between the first 2 x-intercepts. So this would be beginning and ending value for the interval. Since we're on the x-axis, we should be able to include those. So we'll do the brackets. And then the last interval is after the last x-intercept. So we'll have the last x-intercept to infinity. And again, since we can include the x-intercepts, we'll put a bracket on that value. Looks good. Okay, so for more complicated polynomials that we can't necessarily factor, we'll go ahead and use the graphing technology to help us with that. Okay, but we still have to be familiar with finding those x-intercepts. That way we can write our intervals appropriately. Are we feeling okay with that? This graphing x-intercept technique? Okay. We're going to stop there for today because that's the end of this section. So you can use the remainder of the time, which is about 15 minutes or so, to work on some homework problems. I just wanted to let you know that tomorrow is going to be a Zoom lesson with Scott from Oberg. So we're going to have that big screen in here. We're going to pick up with the next section on Thursday.
Try to